Alright, so we're going to look at the case of question 3C, which is probably a problem we've seen hopefully by now. It's a piecewise function. It looks rather gross. It doesn't matter what the piecewise function. Question 3A and B we can solve because they're less than. The probability that x is less than 60 and the probability that x is less than 95 or whatever it happens to be. Question 3C is a bit more challenging. Can anyone see why that might be challenging if we look at our piecewise function? It's greater than. And what's the problem with that if we look at our probability density function? There's no upper bound. What is the upper bound really? Infinity. So if I was doing this problem, I would have infinity, 65, 1500, x minus 50 over x to the power of 4. Cool? We expand that in. I'll just do an equal sign here because I need to. 65 infinity 1500 x over x4 minus 75 1, 2, 3, 4 over x to the power of 4. We cancel that and that. Happy with that? When I integrated that, I'm just mindful of making the board too cramped, but I get negative 15,000 over x squared 2 minus 750000, no, plus. Why did it become plus? Why did it become plus? Yep, where do I get the negative from? What's the power here initially? Well, that one's negative 4, that one's negative 3 really, isn't it? So we've got to divide by negative 2 and negative 3. But I just put the signs on the top. Cool, I know that we've done that before, but we've probably forgotten. Happy with that? So I've got two solutions at this point in time. I can either solve with the infinity, so I can deal with the infinity, and there is a way to do that. Can anyone see what will happen if I solve this with the infinity there? So I would put what do we think is going to happen in the case where, so I'll obviously sub my upper bound and then I sub my lower bound in, correct? What's going to happen when x is equal to infinity? What's this term going to be? What happens when I divide a number by infinity? So if I break something up into infinite pieces, right? So I've got this book here, and I break this up into infinite pieces, what's going to happen? If every person in the world got a piece of this book, that's only dividing it by 6 billion, 7 billion. If I gave every person, if I ripped this up and gave every person a piece of this, how much would you get? You basically get nothing, correct? So infinity is infinitely bigger than that, than 6, 7 billion people. So if I divide something by infinity, what's it become?
Nothing.
0. So divide by infinity squared 0, divide by infinity cubed 0, correct? So I'm essentially, my next line of working would just be 0 minus 15, negative 15,100 divided by 2, 65 squared, plus 75,000,000 over 3, 65 cubed. And I'll just shove that in my calculator. Happy with that? So that's the first way I can deal with it. Pretty tricky. There are benefits and downsides to that. We do need to understand how to deal with things as it tends towards infinity. But as you can tell, that there's probably plenty of opportunities for us to make a mistake in that.
Have we given the infinity in addition? No.
Well, because here there's no upper bound. There's no upper bound, so it goes. So if I was to sketch this function, I'll just do a little version of it up here. So let's just say it looks like that, right? And this is my point 50. That's my x-axis. That's my point 50, and this is my point 65, and I want that area there. Well, it keeps going forever and ever and ever. Cool? Happy with that? With these problems, it is always going to tend towards 0 y because the exact area has got to be what?
1.
What's the total area of these probability density functions got to be?
1.
It's got to be 1, correct? So if it doesn't tend towards 0, you're not going to get an area of 1 exactly. Cool? So the second one I can deal with this is I can say, well, I need to know the probability x is greater than 65, which is equal to what? I'll give you the first line.
Figure it out between 50 and 65 and minus 1.
Yeah, so 1 multiplied by the probability x is less than 65. Cool? Just complementary probability. If I want to know the probability that I've got a head, 1 minus the probability of a tail. If I know the probability that's greater than 65, 1 minus the probability that's less than 65. Good? Nothing crazy about that. So then I can just go 1 minus the probability of 50 to 65 of my function again. I don't want to really write it all out again, but I'm going to.
Tough life, isn't it?
It is. Cool. Happy with that? Now at this point in time, we're going to pause this video and I'm going to get you to play your calculators.